Hi guys, your Friendtor Gopika is here, and in this video we will discuss the theorem which deals with congruent chords and congruent arcs, how they are related. Okay, so the definition of congruent arcs we saw in the previous video. We also saw how to find measure of an arc and property of adding the measures of arcs. So all those things we already saw. Now we will go one step further and learn two theorems, actually one theorem and then its converse. Which deals with congruent arcs and corresponding chords. Okay, so without wasting time, let's get started. Okay, so let's see the theorem regarding corresponding arcs and congruent arcs and the corresponding chords. So the statement says the chords corresponding to congruent arcs of a circle or congruent circles are congruent. That means if you see this diagram, there is a circle with center B, and if arc APC is congruent to arc DQE, then the corresponding chords, that is chord AC, is congruent to chord DE. That is what the statement of the theorem says. So if you have two congruent arcs, and if you join the endpoints and form a chord, then those two chords are also congruent. Okay, so given in a circle with center B, arc APC is congruent to arc DQE. Okay, to prove that chord AC is congruent to chord DE. So the proof, the framework they have already given, it's a fill in the blanks type, so we need to fill few things, otherwise the proof is already written. Okay, so it starts with considering the triangle ABC and triangle DBE. So here we had two arcs and two chords. Then we joined these radii AB, BC, BD and BE, and we got two triangles. One is triangle ABC and another is triangle DBE. Okay, so here if you see the sides of these triangles, both the triangles, they are congruent since all of them are radii. That is, BA is radius, BC is radius, BD is also radius, and BE is also radius. All these four segments are radii of this particular circle. Okay, so segment or side AB is congruent to side DB since radii of the same circle. Again, side BC is congruent to side BE since they are radii of same circle. So in these two triangles we got two pairs of corresponding sides are congruent. Next, third thing, angle ABC is congruent to angle DBE. Why? This particular angle ABC is congruent to angle DBE because it's given that arc APC is equal to arc DQE. Now, measure of the arc is same as the measure of the corresponding central angle. Now, AC is central angle of APC, and DBE is central angle of arc DQE. That means angle ABC is equal to angle DBE. Okay, since they are measures of congruent arcs. That means these two triangles that we have considered, they both are congruent by SAS test. That is, two pair of sides and one pair of angles. Corresponding angles are congruent. So by SAS test, these two triangles are congruent. Okay. Once we prove that these two triangles are congruent, that means the third side is also congruent to the corresponding third side of the other triangle. So AC or chord AC, side AC is congruent to side DE. That means chord AC is congruent to chord DE since they are corresponding sides of congruent triangles. So the short form is CSCT. Okay, that means corresponding sides of congruent triangles. So a very simple proof, we just consider the true triangles when we have two congruent arcs and their corresponding chords. We form two triangles by joining the radii or by drawing four radii, and then we prove that those two triangles are congruent, and hence we get that AC is congruent to DE. Okay, so let's see the converse of this theorem. Okay, so the converse says that corresponding arcs of congruent chords of a circle or congruent circles are congruent. Okay, that means if we have two chords which are congruent, then the corresponding arcs of a circle are also congruent. That means here, suppose this arc chord PQ and chord RS. So these two chord RS and chord PQ, these two are congruent, suppose. So by converse we need to prove that arc PMQ is congruent to arc RNS. Okay. So here the proof is really simple. We consider the following statements and write the proof. The statements or the hints that they have given is: two arcs are congruent if their measures and radii are equal. So one thing that we need is their measures should be equal. Next we need that radii are equal. Now the radii equal part will naturally follow, since if you see this particular arc PMQ and SNR, this radius OR, OS and OQ, OP, their radii is equal, since this lying on the same circle. These are arcs of the same circle, so the radius is equal is trivial, it follows naturally. And if in case, as in the statement, they are not talking about one circle, then they are talking about two congruent circles. If the chords are in two different circles, that is two different congruent circles, then the congruent circles also have same radii. Okay, so anyhow this radius are equal in both the cases. Next, arc PMQ and arc RNS are arcs of the same circle, hence have equal radii. So that is what I just said. Now here this PMQ and RNS are arcs of same circle, so their corresponding radii is naturally equal. If it was on different circles, then too the circles are congruent according to the statement. So two congruent circles also have equal radius. So equal radius part is done. Next, what we need to prove is that the two arcs are having equal measure. That means this measure of arc PMQ should be equal to measure of arc RNS. That is what we need to prove. So here also we can consider these two triangles, and then through SSS test we can prove that these two triangles are congruent. How? Because OP is congruent to OR, radii of the same circle. OQ congruent to OS, radii of the same circle. Third thing, which is given in the question itself, PQ congruent to RS. So all three corresponding sides, pair of corresponding sides are congruent. That means these two triangles are congruent. If these two triangles are congruent, then angle POQ is congruent to angle SOR. So these particular central angles of this corresponding arcs, of these particular arcs, they are congruent since they are corresponding angles of congruent triangles. So here this side POQ is congruent to angle ROS. So this angle and this angle, they are corresponding angles of congruent triangles, hence they are congruent. So once they are congruent, that means the arc PMQ is congruent to arc SNR, because we proved that their measure is equal and their radii is also equal. Okay. So by definition, arc PMQ is congruent to arc RNS. That's it. So I want you guys to try out the proof. I already explained how to write or what are the steps. Just similar to the previous theorem, converse also the proof we can write in a similar way. There we used SAS test according to the given information. Here we will use SS test according to the given information. Here we have information about the third side, so we use SSS test and prove that the angles, these two angles are congruent, and hence PMQ is congruent to RNS. Okay, so let's see the next. Okay, now let's discuss some solved examples. So the first question is, ABC are any points on the circle with center O. So you have a circle with center O and A, B, C lie on the circle, 3 points. Write the names of all arcs formed due to these points. Now this is simple, there are a lot of arcs formed. So AB, arc AB, arc BC, arc AC, arc ABC, arc ACB, arc BAC. Okay, so just list the arcs which are formed. Next question is, if measure of arc BC is 110 degrees, that means 110 degrees, and measure of arc AB is 125 degrees. Okay, so this particular arc BC is 110 degrees and arc AB is 125 degrees. find measure of all remaining arcs. So you need to find measure of AC, ACB, BAC. Okay, so one by one. First thing, we can find measure of arc ABC by simply adding measure of arc AB plus measure of arc BC, since they have a single common point. So we can add the measures and then get the answer, that is 235 degrees. Next we need measure of arc AC. Okay, now full circle is 360 degree. From that, if I subtract measure of arc ABC, then I will get measure of arc AC. So that would be 360 degree minus 235 degrees and hence 125 degrees. Next, measure of arc ACB. So ACB, this major arc. The corresponding minor arc is AB. So 360 degree minus measure of arc AB, that is 360 degree minus 125 degree is 235 degree. So measure of arc ACB is 235. Next, now measure of arc ACB, you can also find it as measure of arc AC plus measure of arc CB. Okay, then too you will get the same answer, since measure of arc AC is 120 degrees plus measure of arc BC is 110. So if you add, you will get 235 degrees again. Okay, next measure of arc BAC, that is BAC. So here also one way is you can add measure of arc BA, that is 125 plus AC, which is again 125. 5 plus 125 is 250 degrees. Other way you can do is, from full circle, if you subtract the measure of arc BC, that is 360 degree minus 110 degrees will give 250 degrees again. So either ways you do, you get the same answer. Okay. Here in the figure 3.36, that is here, a rectangle PQRS is inscribed in a circle with center T. Prove that, first thing, arc PQ, that is this particular arc PQ is congruent, okay, not chord, this arc PQ is congruent to arc SR. Next we need to prove that arc SPQ, that is this full arc SPQ, is congruent to arc PQR. Okay, that is this part to the left. So here this quadrilateral is a rectangle, that means the opposite sides are equal. So PQ, chord PQ is congruent to chord SR. Similarly, chord PS is congruent to chord QR. So these two things you know, since the quadrilateral is a rectangle. Now if chord PQ and chord SR are congruent, that means naturally arc PQ is congruent to arc SR by the theorem that we learnt just a few minutes before. The theorem says if you have two chords which are congruent, their corresponding arcs are also congruent. So arc PQ is congruent to arc SR since their arcs corresponding to congruent chords. That is the reason. Okay. Next part, that is we will talk about arc SPQ and arc PQR. So there what happens, chord PS is congruent to chord QR, right, since they are opposite sides of a rectangle. Now again by the theorem, arc SP is congruent to arc QR since they are arcs corresponding to congruent chords. Okay, therefore measures of arcs SP and QR are equal, right? That means measure of SP is equal to measure of arc QR. Two congruent chords means their measure is equal, their radii is also equal. Congruent arcs means. Okay, now measure of arc SP plus measure of arc PQ. So measure of arc SP plus measure arc PQ is equal to measure arc PQ plus measure arc QR. Now if measure of arc SP is equal to measure of arc QR, on both the sides I can add measure of arc PQ and still the equality will remain the same, correct? Now this SP plus PQ is measure of arc SPQ. Similarly, arc PQ plus arc QR is same as measure arc PQR. So measure arc PQ is equal to measure arc PQR. We proved. Now same circle means the radius is same. Now we also got that these two arcs have equal measures. That means these two arcs are congruent to each other by definition. Okay. Okay, so in today's video we learned a lot of things. First thing that we learned was an angle whose vertex is the center of a circle is called a central angle. Then we learned the definition of measure of an arc. The measure of the minor arc is same as the measure of its central angle. Measure of the major arc will be 360 degree minus measure of its corresponding minor arc. Next, measure of a semicircle is half of the full circle, that is 180 degrees. Now when two arcs are of the same radius and same measure, they are congruent. So two arcs with equal measures and same radius, then we can call them as congruent arcs. Okay. Now when only one point C is common to arc ABC and arc CDE, we can add their measures to get the arc of the bigger arc, measure of the bigger arc, that is arc ACE. Next, we learn two theorems. Chords of the same or congruent circles are equal if the related arcs are congruent. Okay. Similarly, arcs of the same or congruent circles are equal if the related chords are congruent. So, the theorem and its converse.